Hello all, my name is Rahman and welcome back to my YouTube channel. So guys, in this video we are going to do the visualization and the prediction with our support vector machines. So guys, if you remember in the last video, we have done the optimization for the support vector machine and we have applied that with the Python. And guys, with the last video, before the previous video, we also talked about the building the support vector machine from the scratch, and then we have talked about the optimization with the support vector machine. But guys, the main thing, the interesting thing that you know is that up to this point, from these three videos, we didn't run these code, right? So guys, in this video, I am going to run it because in those two videos, I have not done the visualization for that and prediction. Right now guys, in this video, I am going to do the prediction and the visualization for this, and then I am going to run it. Then we are going to get the output as the graphs. So guys, I have already imported the matplotlib, and then we have already imported the numpys for handling the numpy arrays. So guys, we have created some of the, we have a class, and then we have defined some of the definitions, like we have done that in it. We have the training fit, and then again we have a prediction. Right now guys, we have filled these things. Now we have to fill this prediction definition. Now guys, we have the classification right now. Now guys, below this one, I'm going to add here the if statements here. Right, so guys, if that is right, if the classification, okay, if the classification is not equal to 0, and then if it's not equal to 0, and then self dot visualize. Okay, so we have the visualization for this one. I'm going to copy it and paste it here in place of this one. So guys, we have the self dot visualization, and then guys, we have to give here the semicolon, and we have the, if we have given the if statement, then if it's the case, then it should be something like self dot ax, and then it's going to be scatter. Okay, and then if it's scatter, then it should be in the brackets atu features. Okay, and the features should be 0, and beside that one I have the features again. Copy this, and I'm going to repaste it again. And guys, in this one I'm going to paste the features should be 1. Now guys, beside this one, I'm going to use here the colors, and we have to use all of these things, size and etc. Now guys, first of all, here I'm going to use here the size, right? So guys, it's going to be small, and it's going to be this size should be 200, and we need a marker, right, for drawing that one. So let's give it as something like star or something like that, and then later on we have the marker, and now we need a color, right? So guys, for the color, let's give color or let's give c equals to, and then let's give as the self dot colors, and the colors should be the classification. Okay, now guys, we have this one. If this is the case, then it's going to return the classification. Now guys, I'm going to define a new function here, and that is the visualize. Okay, now let's coming back to here, let's define it as def and visualize. Okay, okay, now visualization, and then guys, in this video, in here I'm going to pass it the self parameter. Then guys, beside this one, I'm going to use here the square brackets for this one. Then guys, in the square brackets, I'm going to use here the ax for this one, and then again I'm going to use here the scatter. Okay, now the scatter again with this one, I'm going to again a bracket, a parenthesis, and where we have the x should be 0, the value of x should be 0, and the again we have it should be 1. Now, so guys, these two are different here, and then we need again a size which is going to be 100 now. So guys, at the time we have used the size around the 200. Now I'm going to use here the 100 for this one. Now we have to use here the color, right? So guys, for the color, let's give it as self again color c, and or let's give it color should be equal to self dot colors. We should give colors, and then it should be I. So guys, you have a question that why you have given here the C and here why you have given color, because if I give the color equals to this one and here also same thing, then these two variables are going to be confused. These two variables are going to be mixed here. That's why I have done the different things for these two things. Now in this one here, I am going to use here the for loop. So guys, for doing this one, I am going to use here for x in the data data. So guys, if you remember the first video where we have done we have built in the support vector machine from the scratch, where we have created a we have created a variable known as data somewhere. Let's find it in this page. Data. Okay, so guys, we have done that one here itself. We have the data. Now I'm going to use here the for x in the data, and then guys, now we want to return this one, right? So guys, below this one, I'm going to define a new function, and that is going to be def, and again it's going to be hyperplane. We are going to hyperplane. Okay, now guys, in the brackets, I'm going to pass here some of the parameters like x, w, b, and v. I'm going to talk about this why I'm passing this first. Let's type in x, then w, then v, then b. Or let's use here the b and w here. Or v. Okay, now guys, you have this one. Now we want to return this one. So guys, we have a question that what we want to return here. So guys, we have a formula for the hyperplane, and that is going to be hyperplane equals to x dot w plus b. So guys, x into w plus b, we have this one, guys. Now for the hyperplane, the formula is x into w plus b. So guys, coming back to here, below this one, I am going to use here another comment line, and then I am going to give here something like b equals to x into w plus b. So first of all, why we have given this b equals to x into w plus b. Now, so guys, the reason that we have given here v equals to x into w plus b is that here we have given the parameters also we have used here the v, right? Now guys, what this v does is it's going to give the value to the hyperplane equals to x into w plus b, right? Now guys, what we are doing is we are seeking the value of the v here right now. So we want the value, so it's going to give the value for the hyperplane. Now guys, after this one, I'm going to so guys, what we have a question that what we have to return here, right? So we have in the parameters we have returned the hyperplane, and then we have the x, w, and b, x, w, b, and w. So these are the parameters. But guys, what should we return here? So we know the value of x like x into w plus p, and we don't know the value, but we know why we have given x, w, b, and v. So x into w plus p, and we have used the v for the giving the values, right? Now guys, what you have to return, we have a question, right? So guys, for returning, I'm going to give here some around here, right? Now guys, here instead of this one, in this bracket, in this parenthesis, I'm going to give here the minus w, okay, and then the value, the index should be 0, minus w index 0, and then it's going to multiply this with the x minus, so x minus, and then it's going to be plus b, minus b plus b, right? So guys, this is what we want to return here. But guys, after returning this one, what you have to do here is that we have to divide this one, right? You have to divide this by the w1. So guys, what we are doing here is actually we are the minus w, okay, the minus w of the index 0, and then we are multiplying that with the x, and then we are with the minus b plus b, and then guys, we are dividing this with the w1. So guys, do you know the interesting thing about the code that we are writing here? Do you know that? No, right? So guys, the interesting thing that we are doing here is that we are writing this code, all of this code, not for the support vector machine. We are writing this code for the matplotlib, because we have to draw here the graphs, we have to do here the visualization, right? So that's why we are writing this whole code for the matplotlib. So guys, the things that you are seeing like scatter self.ax.scatter, the things that you are seeing are, we are doing this for just for the graphs. We are doing this just for the matplotlib. So guys, now we have to do some of the predictions, and we have to do some of the stuff for the visualization, right? So first of all guys, let's complete the work for the visualization. Now we have the def hyperplane, etc. Now guys, I am going to create here a new variable, and that is data and data range, something like that, range. Now guys, we have the data range equals to, and guys in the brackets I am going to give you something like self dot min. I am going to copy this. Where was I? We are going to have the min feature max feature value, right? And we are going to have the, again, okay, let's copy this only. Now we have the self dot max feature value, but guys, we are going to change it into the min feature value, minimum feature value. Now we have the minimum feature value, and guys, we are going to multiply this with the 0.9, okay, but value into, okay. So guys, we are going to multiply the min feature value with the 0.9, and then we are going to multiply the self dot max feature value with the 1.1 here. Now guys, here I am going to, what I am going to do is I am going to give you something like hype, then we are going to give the x, and then we are going to give the min, hyper x min. Now instead of this one here, I am going to use something like data range, and guys, I am going to give it the 0, guys, because this is the indexing 0. So guys, you will be asking like why I have created this variable. So guys, you will be knowing that because for each and every time I have to write this after a hyperplane equals to this one, something like this, right? So I'm going to paste this one again, this whole line. Let's copy this, and I'm going to repaste it again. For the hyper x max, I'm going to give max. Okay, now we have the max, it's going to be 1 here right now. So now what you have to do is, if you remember guys, in some videos before, we have talked about the optimization, constraint optimization with Python, not with Python, I have just explained that on the whiteboard, right? So guys, at that time I have talked about the w into x into w into x plus b, something like that, right? So guys, the formula is, I am going to show you w into x plus b, and guys, you are getting a value where you are getting something around positive. This is for the positive, and then again we are getting the value for the negative, -1, and again you are getting the value for the 0. So guys, the value for the 0 is the decision boundary, right? So guys, we have to write all of the code for this one right now. So guys, for writing, first of all, I am going to write the code for these positive ones, right? So let's give positive, and yes, positive support vector machine hyperplane. Now guys, what I'm going to do is I'm going to write something like positive, let's give as positive ps1, let's give ps1, and then ps1 equals to hyperplane, and then guys, in the brackets I'm going to use here the hyper, and hyper, then x, then max, so then min, and then we have to give the something like self dot w comma self dot b, right? Now guys, beside this one I'm going to give here the 1, because this is going to be positive 1. Now I'm going to copy this whole line with this one, copy it, and then I'm going to repaste it again. We have the ps1, right? Instead of this one, I'm going to paste here into ps2, and then we have the hyperplane, it's going to be the max self.w, and we have the 1. Now guys, what we have to do is we have to type something like self.ax.plot, right? Now guys, we have the self.ax.plot. Instead of this one, let's try to copy from somewhere else. Did we return this one? No, x.scatter we have written, not plot. Okay, now guys, here I am going to create the brackets, and guys, in this one I am going to give hyperplane, and then x, and then min, let's give, and then comma, let's copy this, paste again, let's x max here, max for the max, and now I have to give the comma again beside this bracket, which is where we have this beside this square bracket. And then guys, I'm going to create a new square bracket where I will be giving something like ps1 comma ps2, something like this. Now I'm going to remove this space from here. Now guys, what I have to do is we have to copy these whole lines, and then guys I'm going to let's paste it again, and then I'm going to paste it again. Now guys, this is just for the what we say that you are seeing here, wx plus b equals to 1 is just for the positive. Now guys, we have to do for this decision boundary equals to 0, and we have to do for the minus 1, right? So guys, this is going to be minus 1, and this is going to be negative. Okay, now guys, negative for the negative 1. Now below this one we have the hyperplane. Now negative, let's give as ng here, also ng2, hyperplane, hyper x min, this should be same, and this is going to be minus 1, this is going to be minus 1, and here also ng negative again, negative. Now we have the hypermax, and these things should be same here right now for the negative 2 and negative 1. Now we have done the thing for this one also. Here it's going to be 0, which is going to be, wait, I'm going to talk about that decision boundary, right? So guys, now guys, if w into x plus b equals to 0, then the line, then the hyperplane is on the decision boundary. Okay, then the hyperplane is on the decision boundary. Now I am going to give here the positive. I am going to remove this one. So guys, for the decision boundary, let's give for the decision boundary something like db. Now guys, for the ps, instead of this ps, I am going to remove this one, and then I'm going to give the db for this one decision boundary, and db for this one also, and then here also 0, not instead of 1, 0, here also 0, and then guys, here it should be db again, db1, db2. Now we have the self.ax plot. Now guys, what I have to do is, the main important thing is that we have to use it, we have to plot this one, right? Now guys, for plotting, I'm going to give something like p. Let's remove this one. Now guys, let's run it, something like plot plt.show, and then I'm going to give it the brackets. Now guys, we have this, all of these things. Now below this one, instead of this one, let's do that here. I'm going to create here something like SVM equals to, and then it should be support vector machine, the class that we have created here, SVM, right? So we have to give here also same SVM, and then it should be just brackets. Below this one, it should be SVM dot fit, and then guys, it should be data dot data. Okay, and then guys, it's going to be, we have to do here the prediction, right? So guys, we are going to do that later on. Then let's do this SVM dot pis, visualize that, right? Visual confused. Okay, so anyway guys, now I am going to run this one from the top of it. Now guys, finally in this video we are going to run now, right? Now let's see, this is run just now, but guys, anyhow I'm going to get some errors because I have not checked all of this one, right? Then let's run it. Self max value. So guys, you have the indent block in the self.max feature value, max all data. We have to search for that one, max. Here we have done the mistake. Self.max feature value equals to max all data we have. So guys, the errors that from the time that we are getting was around somewhere self dot here, right? Self.max feature value, because here we forgot to add this line, all data dot append features. Guys, this is the main line, right? So guys, I forgot to add this line only. So guys, this is why we got the error. And again guys, at between I got another error where I got this line, where I got this star, something I have given something like this. Then when I gave them in the quotation marks, then I didn't got any errors, right? Now And then guys, in between I got other lot of errors, like for example, if I show you one more here. Okay, so we forgot to add this for x in data. We have forgot to add this one also. So guys, anyway guys, now it's working. So if I show you from the top of this, if I run it and show you and run all of them. So guys, as you can see here, we are getting this something like optimized step till the time. So from the time we're getting all of these things, right? Now guys, if we go to the very bottom of this page, let's go very bottom of this page. And now guys, as you can see here, we are getting the optimized step. From the time we're getting, now guys, we are getting the lines in a different way. So guys, this works, right? Now it's working here right now. Now guys, what you have to do is you have to add here the predictions. But guys, you don't need to solve all of these errors, because I'm going to give this code link in the description below, GitHub link, so you can go there and copy the code easily. Now guys, let's add here the predictions. So guys, for doing the predictions, I have copied a code. So instead of this one, I'm going to make here a new cell below this one, where I'm going to paste this block of code where we have the predict as all of these things. And instead of, now guys, we have this one, right? Now we have to remove this from here. We have to copy this, Ctrl X, delete this one. Now here below this one, I'm going to make a new cell where I'm going to paste this one, and then I'm going to remove this from here, and then I'm going to paste it. Okay, now save it. I'm going to remove these things, save it. Now I'm going to run it from the top of it. But guys, when I'm running that, I'm getting some errors, not some errors, I'm getting the colors mixed here, right? So guys, for seeing those colors, let's give for the black color, let's give the black for this one, and here let's give the black. And then guys, for this, if it came to the decision boundary, then I want to be something like the decision boundary should be something in the green color. Let's run it. So guys, here we got the black. Okay, so guys, this is because we haven't given the comma here. Now let's give the comma again, and here also we have to give. Okay, now save it and rerun it. All of them, optimized step, and then if I run it, visualize, I'm getting the fit data, and then guys, let's wait till it comes to the very bottom of this page of this output. Okay, now guys, we didn't got any output here. So guys, I think this is because if I show you, we have the support vector machine and we have the fit data, and then guys, what I have to do is we have to do the visualize here, right? So let's remove this, visualize, remove this, and then I'm going to paste it and run it. Then nothing happened. Okay, so we have to do the predictions, and we have the predict as. We have created this one variable, and instead of this one, we have the prediction for p in predict as. We have the support vector machine. So guys, let's do a thing, copy this one, and then I'm going to let's do here, save it. Okay, let's copy this, and I'm going to paste it here, save it. And guys, I'm going to remove all of these things from here, and if I come here, paste it, and guys, I'm going to cut this one, run it. So anyhow guys, we got all of these things. So guys, as you can see here on the screen, now we are getting, because at the time we were shuffled the code that, right? So now guys, as you can see here, we are getting these dots, this group of dots, and this group of dots, and guys, we are getting a green line and a black line. Okay, so anyhow guys, that's all for this video. I hope you liked this tutorial of the visualization and prediction with the support vector machine. So please make sure to subscribe to this channel, like this video, and share this with your friends, and I will see you in the next tutorial. Thanks for watching. Thank you. Bye.